Hi students, welcome to the solution for the mastery worksheet for mole concept. Alright, so let's begin to take a look at the challenging questions with question 1 first, which is on page 8 of your notes. If you take a look at question 1, you'll notice that the question wants us to find out the number of atoms in 12 grams of carbon. Carbon is represented by C with the chemical symbol. So first thing first, do you recall what formula should you use? Yes, in order to convert from grams to number of moles, we actually have to use this formula that you see over here. The formula tells us that the number of mole is equivalent to the mass divided by the relative atomic mass or the relative molecular mass. In this case, it will be 12 for carbon. Next, using this calculation, we can find out the number of atoms by simply multiplying it by the Avogadro's constant, which is 6.02 times 10 to the power of 23, and that will give us 6.02 times 10 to the power of 23 atoms in the mass of 12 grams. Let's take a look at the second question. To calculate the number of atoms in 106.5 grams of chlorine atoms. Similarly, you'll notice that the mass itself cannot be directly converted to the number of atoms, hence we'll first convert it into the number of moles. But take note that chlorine by itself exists as Cl2 molecules, right? But the question is asking for atoms, so 106.5 grams of atoms is actually based solely on the relative atomic mass of 35.5, which is that of a single chlorine atom. So the number of moles is equivalent to 106.5 divided by 35.5. Likewise, using the second triangle formula, we can actually use this to calculate the number of atoms in this case. Now that we have to look through how the two formulas can be combined together, let's take a look at question number 3. This time round, you're asked to calculate the number of atoms in 28 grams of nitrogen molecules. So take note that nitrogen molecules is represented by the formula of N2. But the question wants to know about atoms. So you must first understand that within an N2 molecule, there's actually 2 nitrogen atoms. This will affect your calculation of the total number of atoms, as you have to take into account that conversion. You may wish to pause the video now to try it out on your own. I hope you have managed to try it out and take a look at the answer now. Notice that in the final calculation of the number of atoms, the teacher actually multiplied the number of moles by 2 because every one nitrogen molecule has 2 nitrogen atoms. Now, let's take a look at another question. So if you're now asked to calculate the mass of 2.4 dm³ of carbon dioxide gas, can we take a while to think about what kind of formula do we need? We are given a gas and a certain volume. Yep, you're right. The formula that we need to apply over here is to use the formula that involves the molar volume of 24 dm³. So the formula triangle is as shown over here. The number of moles of carbon dioxide is equivalent to the volume divided by 24 dm³, which is the molar volume, and that will give us a value of 0.1 mole. Using this value of 0.1 mole, we can then calculate the mass of the carbon dioxide gas by applying the triangle formula as shown over here. So the mass of this amount of gas is actually equivalent to the number of moles multiplied by the molar mass, which is in this case is the same value as the relative molecular mass, which is 44. And that will give us the answer. So you notice over here in this question itself that you actually have to combine two formula once again, but this time around using the formula that involves the volume of gas in this case. So it shows that when you read a question, do take note of what are the key values that were given in the question itself before you start to attempt. If you look at the second question now, have you understood how to solve this? If so, please pause the video now and try the question out on your own. Alright, now let's take a look at the solution. Now, what if the question actually gives us the 17 gram of a gas? That means it gives us the mass but asks for the volume. If you think about it again, the idea is still the same. If given the value in mass, how can we find out the volume when the two equations are not even involved? First, let's always convert it to the number of moles. So, 70 grams of ammonia gas can be converted into the number of moles by dividing it by the relative molecular mass, which is 17 as well, and that will give us 1 mole. Now, with this 1 mole, we can calculate the volume of the gas by applying this formula triangle to allow us to multiply it by 24 dm cubed, and that will give us the answer of 24 dm cubed. Now that you have understood how to combine these two equations together, how about you try this out on your own for question 7. You may pause the video now to try out the question before taking a look at the solution. Now, let us move on to something that's more difficult, which is on concentration. A solution of iron 2 nitrate has a concentration of 4.5 grams per dm cube. As you see the unit of grams per dm cube on concentration, you should start to think about what formula actually involves this unit. And this formula can be shown using this formula triangle of concentration in grams per dm cube is equivalent to the mass divided by the volume of the solution. So somehow, once you see this value, you should think immediately of this formula, because it means that maybe you will require this in the solution, and most likely this will be the case. Yes, so for relative molecular mass, I believe that most of you will still remember how to do it, so the value in this case should be quite straightforward for you. But now, what if the question asks us to convert from grams per dm cube into mole per dm cube? Well, there's actually a shortcut which your teacher has probably already shared with you, which is to go from grams per dm cube to mole per dm cube. You simply have to divide it by the relative molecular mass of the substance. Therefore, in this case, the concentration in mole per dm cube for iron 2 nitrate solution is equivalent to 4.5 gram per dm cube divided by the relative molecular mass, which is 180. That itself will give us the concentration in mole per dm cube. And this is a very fast shortcut for you to convert the two values. However, if you really want to understand how this works, try to think about it. 4.5 grams per dm cube actually just means there's 4.5 gram of the substance in 1 dm cube of the solution. And this 4.5 gram, we can simply convert it into the number of moles by dividing it by the relative molecular mass. In this case, it will give us 0.025 mole. In other words, this means that there is 0.025 mole of the iron 2 nitrate inside 1 dm cube of the solution. Therefore, this means that the concentration in mole per dm cube is 0.025 mole per dm cube. And that's the reason why we can use the shortcut to simply shorten the process of calculation. Alright, now that you have understood how this works, maybe you can try to apply it onto the next question, because it somehow revolves around the same concept. You may wish to pause the video now so that you can have time to try out the question before watching the solution. Now, if you take a look at part C itself, how many moles of ethanoic acid are there in 35 cm3 of the solution? Well, if you want to find the number of moles in a solution, most likely you have to apply this formula triangle as seen over here, because this is the only formula that relates the concentration of a solution to the number of moles that's present within it. But what exactly does this question means? Well, first you have to understand the concept of concentration. For instance, if you take a look at this particular diagram over here, you'll notice that the one on the left side actually represents the concentration, because it tells us the number of particles inside 1 dm cube of the solution. Now, what the question wants us to do is to derive that what if the volume that we're looking at now is just, say, x dm cube, or in this case 35 dm cube, how many particles will be inside. Therefore, in this case, that's when we apply this formula to help us derive that. So to show the formula triangle again, let's take a look. Concentration is equivalent to mole over volume. If you want to find out about mole, like what you have learned, we'll just cover up mole itself and that will give us concentration multiplied by volume. But do take note that the volume given in this question is 35 cm cubed and you have to convert it into a value of dm cubed, which is 0.035. With that itself, you will be able to determine how many moles of particles are actually present inside just 35 dm cubed of the solution, and that's equivalent to 0.015 mole. So that's how you solve this question. Let's take a look at another example. By now, you have noticed that in this video, the teacher always underline and circle the values that are given. Why did the teacher do that? Because as the chemical calculation gets more and more complicated, you start to see more and more values being shown in the question. And it's important that you identify which values are important to you for you to start the question first. So if you're asked to find the concentration in grams per dm cube, recall the formula triangle. In this case, it looks like this. So to find the concentration, I simply have to take the mass of the substance, which is 49 grams, and divide it by the volume, which is 500 cm cubed. But once again, I have to convert the volume into dm cubed. As usual, for relative molecular mass, you should be able to find it out by yourself. So there's 2 hydrogen, which gives us 2 bracket 1, plus 1 of the sulfur, which is 32, and 4 of the oxygen, which gives us 4 bracket 16. Once again, you'll notice that the question is asking us to convert the value of concentration into mole per dm cube again. So take some time to recall why exactly is a shortcut to do so from grams per dm cube. Yes, you're right, simply divide it by the relative molecular mass. In this case, that value is 98. So let us do the calculation quickly and let's see what is the value that we derive. Now, this question once again is asking about the number of moles within a certain volume of the solution. Recall what we mentioned just now? How do you transfer the value of concentration and use it to apply to find out the number of moles that's in a certain volume of the solution? Try this question out. You may pause the video if you want before looking at the solution. Now that we have come to the end of this solution series, you will notice that to find out about the different values, sometimes you have to combine a series of equations in order for you to derive it. But most importantly, whatever value you are given first, do make an attempt to find out the number of moles that it refers to. For instance, if you are given 5 grams of carbon dioxide, first find out what exactly is this 5 grams in the number of moles. And that's all for today. Thank you.